Okay, keep quiet, please. Hello everyone, I'm really glad to see you here again. In today's presentation, you are going to take some information about computer networks. As our presentation contains much animation, it will take so long time, and I would apologize in advance for this time. It is a team presentation, and I'm a leader of this team, and we have two more members, Batiusu Dominic and Sadu Lifestyle. We divided our presentation into three parts. In the first part, you will get some information about loss, delay, loss, and throughput. In the second part, you will be informed about protocol layers. In the last one, you will know how the encapsulation works and how it operates. Okay, first, before going deeply, let's get to know about router. What kind of equipment it is? A router is a networking device that forwards data packets between computer networks. Routers perform the traffic directing function on the internet. There are two types of router, wired router and wireless router. You already know about them. We also have data. Data can be music file, video file, or HTML and email. And data sent through networks is in the form of data packets. Now pay attention. We have two hosts, the source host and the destination host. And the first host wants to send the packet to the destination. What happens here? Packets will go through each router, and in each router, some delay occurs. You see, delay in the routers. And what kind of delays they are? Nodal processing delay, queuing delay, transmission delay, and propagation delay. And all of them call it total nodal delay. The first is processing delay. When host sends a packet to the router, some bit level errors occur. The time required to examine the packet header and determine where to direct the packet is the part of processing delay. And the time needed to check for bit level errors in the packet is the one factor of processing delay. After all this process, our packet will go to the queue. Typically, processing delay is less than or equal to milliseconds. Next, queuing delay. Each router has output buffer. When hosts send packets, each packet just goes in this output buffer, and it continues until the buffer is full of them. You see. And the first packet is here being transmitted, while other packets are waiting for it. Here, packets queuing delay occur. Time waiting at output link for transmission depends on congestion level of router. If congestion level is higher, so our process will be quicker. And host sends another packet. If the buffer is full of other packets, this packet will be dropped, and it's called packet loss. Next, we have two routers, router A and router B. Transmission delay. Two hosts send two packets. And here, first come, first served rule operates. Let's consider L, the length of the packet, as the length of the packet, and R as the transmission rate of the link. For example, if our link 100 megabytes per second as a link, this link, so here error would be 100 megabytes per second. And the transmission delay is L divided by R. Another example, we have 120 megabits packet, and transmission rate of the link is 2.5 megabytes per second. The transmission delay is the answer you can see here, 48 seconds. Next, propagation delay. After our packet is transmitted, it will stay at the beginning of the link here. The propagation delay, the time required to propagate from the beginning of the link to the router bit. The propagation speed of the link is equal to this number. It is just equal to the speed of the light or length of it. And the speed also depends on whether our link is twisted pair copper or fiber optics and others. Let's consider S as a propagation speed of the link, and D the distance between router A and B. So in this case, the propagation delay would be D divided by S. One more thing, store and forward. Entire packet must arrive at router before it can be transmitted on next link. Here you can see all the delays, and total nodal delay is equal to all the delay. In this picture you can see all of them. The last thing, throughput. We have server, and we have just host B, host A and host B, and we have one movie file. We want to send it from host A to host B. What happens? Here, the instance throughput at any instance of time is the rate at which host B is receiving file. Our file FBs, and transfer takes T seconds for host B to receive all FBs. So here the average throughput will be F divided by T. F divided by T. Now, let's consider bits as a fluid and communication links as the pipes. Just imagine, host A wants to send bits fluid from this channel, from this communication link, but bits less than the transmission link of this communication link. It cannot pipe bytes, fluids. If R is less than RC, you see, our bits go through without any barrier to the destination host. So throughput here will be RS bits per second. Vice versa. You see here, fluid will come here, and it will take some time to be just transmitted. End-to-end throughput of RC. Bottleneck link. Link on end-end path that concentrates end-to-end throughput. Thank you.